Hi, my name is Femi, and I'll be doing the advanced question for the quideo chapters 9 through 11. So the question says, a researcher believes that treating seeds with certain additives before planting can enhance the growth of plants. An experiment to investigate this is conducted in a greenhouse. From a large number of Roma tomato seeds, 24 seeds are randomly chosen and 2 are assigned to each of the 12 containers. One of the 2 seeds is randomly selected and treated with the additive. The other seed serves as a control. Both seeds are then placed in the same container. The growth in centimeters of each of the 24 plants is measured after 30 days. These data were used to generate the partial computer output shown below. Graphical displays indicate that the assumption of normality is not unreasonable. Determine if there is a significant difference in growth between the tomatoes with additives and the tomatoes without. So, I set up my phantoms, P standing for parameter, H for hypothesis, A for assumptions, N for naming the test, T for the test, O for observations, and M is for making a decision, making a statement. So, in this particular case, the P would be the difference of plant growth with and without additives. So, building from that, we can move on to the H, which is our hypothesis. So I picked mu d, which means the mean of the differences, and the differences would mean the d stands for the mean growth of the control group minus the mean growth of the treatment group. So our null hypothesis is going to be that the difference is equal to 0. So that means that there's no difference between the mean growth of the control and the treatment group. However, our alternative hypothesis is that the mean difference does not equal 0. So this could be that the treatment is more or the treatment is less, grows less or grows more than the control group. So what that basically means is that the control group grows less or more than the treatment group. Because not equal to 0 could mean more than 0 or less than 0. So our assumptions are, well, in the question it says that they were randomly selected, so that's an SSR. And then, however, our number has to be greater than 30. Since we have 24 in this case, we will proceed with caution. And yes, they're independent. So for this one, for this test, we'll be doing a one sample t-test, which is a matched pairs because we're doing the difference. So our formula is the t-score equals x bar value minus the mean all over the standard deviation divided by the square root of n. So looking at the computer output that they gave us, we see that the mean is negative 2.015. That's the difference from the control. That's the difference of the control and the treatment group. Minus 0. Why is that 0? Because up here we're testing to see if it's not equal to 0. So that would be our mu. Divided by 1.163 divided by the square root of 12. 1.163 is given to us, and there's 12 seeds per sample, so we use 12 here. And we get a t-score of negative 6.00. Well, you might say, well, there is no negative numbers in the t-chart. Well, it doesn't matter. You can just say that it's 6.00. It's going to give you the same answer. So, plugging this into my calculator, I got a p-value of 0.00008902, which is the same as 8.902 times 10 to the negative 5th power. So, oh, by the way, for our test, we need to know that the degrees of freedom was 11. How do we know that it's 11? It's the smallest sample size minus 1. In this case, both sample sizes were 12, so minus 1 would be 11. And our alpha value we picked before the test was 0.05 because that's the best, that's the most, how should I say it? The best, yeah, let's just go with best. The best alpha value to use. So, for our statement, to conclude this whole test, we say we reject the null hypothesis. Our p-value, which we figured out up here, or down there, is smaller than our alpha value, which was 0.05. So, we can say that there is a significant difference for the growth between the treatment and the control group. Thank you.